organics, and we'll keep going on to our aromatic compounds section here. We have things like toluene, which we've already talked about, but there's styrene, so there's a double bond inside of there. If you add an N3, it's a neo. If it's benzoic acid, it's a big one that happens and stuff like that. So if you have a phenol group or a benzyl group here, and you add this, it's benzoic acid. So that's benzoic acid. We already talked about ethylbenzene. This is nitrobenzene, phenol. So they all have different names. And again, these come from the idea that before the compounds could be named, through this IUPAC thing, they had already come up with these names. And so this is really important to kind of keep in mind. There's a lot of different names. I'm not expecting you, except for the BTEX compounds, to really memorize those, because those are really super important. Just to give you guys something else to think about, if you have this as a functional group, like say this is stuck onto whatever organic molecule it is, this is a phenyl group. So an example of this would be, and we're going to be talking about this again later on, is diphenyl trichloroethane. Whoa, I know, that looks really long. It is abbreviated DDT. So this is DDT. So when I first looked at this, I'm like, okay, ethane. Okay, that is, because there's a couple different ways, because there's no numbers on this. So I was like, okay, I could come up with a whole bunch of different ways to draw this, but I'll just kind of walk you through how they came up with their name on this. So ethane, so 2 carbons. So we got our 2 carbons here. There are 3 chloro groups connected to our carbon. So chloro, chloro, chloro. Okay? Then we have 2 phenyl groups connected onto it. So this other carbon here has a phenyl group connected to it, and then it has another phenyl group connected to it. And then there's 2 chloro groups connected onto that. So chloro over here and chloro over here. So that is dichloro, diphenyl, trichloroethylene, ethane, but DDT. So DDT, you guys will be talking more about it when we talk about pesticides. This is the main compound that is used for when we talk about silent spraying. So this is DDT. So what do we know about it? Well, I've already talked about this. When we have this carbon-chloro bond, we know that it's man-made and it causes cancer. So we immediately should look at this and be like, whoa, okay. But this is the structure for DDT. So dichloro, diphenyl. So now you can see where this phenol group comes in onto a group on here. Another thing that is linked into these DDTs, linked into DDT here, is this idea of, paper straight here, is PCBs. We already had PAHs, so now we're getting into PCBs. PCB stands for poly. The C stands for chlorinated. And that should automatically set up alarm bells for you. The B stands for biphenols. So PCBs. So they're polychlorinated. So there's multiple chlorinated compounds in here, and there's 2 phenol groups associated with them. Okay. So the classic one for these are also referred to as chlorinated naphthalene. So what was naphthalene again? It was 2 of these together. If we stick a couple chloro groups onto it, if we stick 1 onto it, this one is 2 chloronaphthalene. into there. So that's that. Biphenyls actually look like this. Oh, wrong one. Let me try this again. So this is a biphenyl group inside of there. Chlorinated naphthalenes can have anywhere from 1 to 8 chlorine groups connected to it. So you put one there, one there, one there, one there, there. So any of these can have chloro groups to it. So you can put a lot of chlorines into it. Again, better living through chemistry. A lot of great things that can happen with carbon and chloro groups. So some classic ones that come out of these chlorinated biphenyls too, or chlorinated compounds that you might have heard about too, are CFCs. Yeah, get that over. CFCs. Well, what does the CFC stand for? It stands for chlorofluorocarbon. Carbons. So CFCs stand for chlorofluorocarbons. Well, now you know what a chloro is. You know what fluoro is. Well, what do you mean by carbons in here? Usually these are 1 and 2 carbon compounds, so they only have a couple carbons, so they don't have this phenol group into them, that contains chloro and fluoro bonded to the carbon. Okay, so that's what a CFC is. So CFC11 is CCl3F. CFC12 is CCl2F2. They do not contain any hydrogens, so no hydrogens in these compounds. Otherwise, they're halocarbons. But CFCs are all contain these things. They can contain bromine, so they could be bromo. So CFCs. So where have we heard about CFCs before? Those are refrigerants. They were destroy the ozone layer. They're used a lot for refrigeration into there, especially this chloro group. This chlorine, if you haven't looked up how the ozone layer gets destroyed with chlorine groups, make sure you understand that. It's actually a really great story, because we actually started banning certain types of compounds. They still get out, but we started banning them. And it was like a world, we decided to ban it. The whole ozone layer was starting to get better, things like that. The cool thing about CFCs, and this is where it falls into the hydro community instead of the atmospheric community, is we can use these as groundwater tracers. Okay, so they get into the atmosphere, and we can look at date and times, and we know how much of these were produced, and when there's like these large spikes of them in our atmosphere, well, they come out with the rain. And so we can actually look, and these don't break down in the environment, and we'll talk more about this with biodegradation and with remediation, and we'll talk a lot more about this later on in the semester. But basically, when you have this carbon-chloro bond, it's very hard to break down. We've already talked a little bit about PCE to TCE to cis-DCE to vinyl chloride to ethene. We talked a little bit about it. We'll keep coming back to some of these topics. Again, I do a very kind of secular way I teach. But these compounds here, we can put them into groundwater, so we know what concentrations they were. They don't break down in the environment. They don't really stick to anything, and so we can actually age date groundwater based upon the concentrations of CFCs. So it's one of the ways we can age date water. It's got some issues and problems. If you take a hydro class, we could talk about age dating groundwater, but CFCs, or your chlorofluorocarbons, because they've got no hydrogens, but they've got these things, really important for our perceptions of the environment. So big things, CFCs. We are going to be talking about DDT. It's good for you and me. I'll show you guys a thing on that. And we talked about PCBs. So this afternoon we did CFCs, DDT, and PCBs, all within a second here. You see? You love it? You guys just got a whole bunch of new abbreviations, new multi-letter acronyms, so into your repertoire of words. So make sure you know what a PCB, a CFC, and a DDT is. And just some other little side fun ones for you guys. Oh, I didn't bring it today. Oh, maybe I'll bring it on Friday and show it to you guys on Friday. So I had this flask that a friend of mine gave to me, and on it had an organic molecule. And I'm like, ooh, okay, because it was, he thought, oh, you like science and stuff like that. And so it had this organic molecule onto it. And I didn't know what it was, so I'm naming it like we would do in this class, and then I figured out what it was. And it's vanilla, actually. So, but I'll show you what that compound looks like, just because it's kind of fun. So when you taste vanilla, also another side note on vanilla, in other cultures, in American culture, when we smell vanilla or we taste vanilla, we think sweet immediately. Like if we smell vanilla, it's sweet. Other cultures don't have that impression. It's just it's a cultural thing with Americans specifically, that, and we love those vanilla candles and vanilla things. It's sweet to us. Other cultures just are like, okay, but we always perceive vanilla as sweet. So what is the compound itself that tastes like vanilla? What is it? Well, vanilla is our organic compound, because remember we talked about it being aromatic and it has a smell to it. Okay, it's OCH3 over here. It's got an OH group here, and then it's got a C double bond OH onto it. So that is vanilla. And so when this was on my bottle, I started going, okay, that's a phenol group. This right here is a benzoic acid. Or not benzoic acid. What is this one? Oh, this is a benzyl dihydride. Okay, and then this OCH3 here is an anisole, and then I started putting them together, and I'm like, okay, this, and I typed it into the internet, and it came back vanilla. So I was like, ooh, cool. Another one that's kind of an important one is methyl salicylate in here. So we got our benzyl group. Didn't draw that very well, but that's okay. OH group onto here. C double bond O onto a CH3. So this is methyl salicylate, or better known to you as oil of wintergreen. So if you smell that oil of wintergreen or wintergreen gum and stuff like that, they're putting this compound into it. Like vanilla, you can manufacture this. And so what happens a lot of times in not natural, like in candles and stuff like that, they just manufacture this compound and they put it into it. And then when we smell this compound, when it interacts with our noses, this smells like vanilla to us. It doesn't have to come from a natural source. It can actually, we can manufacture this, we can manufacture oil of wintergreen. It doesn't have to come from anything. So just some other little side notes. Fun with organic chemistry. Okay, that's it for today. I hope you guys have a good time. We will see you on Friday.